Okay, so we're going to use TinkerCAD to design the circuits, the LED circuits that we need to make. So if I just look up TinkerCAD and I go here, I go TinkerCAD, and it's going to load. It's also used for like 3D modeling and design, but they actually have a circuits feature now too. Now I'm already logged in, but if we want to show you what that looks like, let's log out. And it'll be your landing page. Autodesk is kind of the company that makes TinkerCAD, same company that we use in our engineering software as well. And stalling for it to come in. All right, so here's where we should land. If you go to the top right and log in, you should be able to just go to student accounts. I'm going to go to educator, but since I have an educator account, you go to student accounts, you should be able to sign in with Google. I'm pretty sure. And if not, there's other ways to log in as well. You just create an account, and it's going to take forever to do it because I'm recording, and that's how it works. But this will be a little true to form with the LEDs that we're using, and it'll look just like the breadboards that we're about to create. So if I go to the top right and I go to create, I'm going to go to circuits, and it's going to give us kind of just a blank canvas to work from, and all of our stuff is on the right that we can build with. So we have LEDs, we have resistors, and notice when we choose these things, we can name them certain things, we can change the values of them, but I'm also going to pull a 9-volt battery. I'm going to scroll down a little bit, and I'm going to get a breadboard, a small breadboard. Let's see, can I rotate this? Yeah, okay. So I'm going to rotate it this way. Well, you know what? No, I changed my mind. I'm going to take it back. We can do it here. So I have my 9-volt. If I like plug it into here, I can plug it right in. Now in real life, I probably wouldn't do that. I'd have wires. So if I click anywhere along here, I can click a wire with the first click, and then the second click is where it's going to land. Boom. Now if you notice, when I highlight these, any dot and that opening here, the whole row lights up green because all of those are connected. It's a way to basically plug in anything to that terminal of the battery. So if I go to, because I like to be color coordinated, the positive side, the red, positive, and I put that to, oh, I did it backwards. Oh no. It's okay. It's okay. I can fix it. I'm going to turn it around so they line up again to satisfy my own neurosis. That's all right. Positive to the positive. There we go. And then I oh no, I'll undo that. And then I'll do another one, negative to negative in black. There we go. So as I was saying, the whole row lights up because this whole row is connected on the back side. So anywhere you put here, it's kind of like connecting to the same spot. Likewise, all of the columns here are connected as well. So any of these 1, 2, 3, 4, 5 spots are all connected together. Nothing's connected across the middle. So these 5 are independent of those 5. Okay, so let's throw in some LEDs. Ready? I'm going to drop this in. Let's drop it in right here. And let's get a few more where my LED's at. Drop that in next to it and drop this in next to it. Let's scoot that over, line it up. Oops, thought I drew a thing. This will work with a touch screen as well. Some things better than others. I'm going to line this up with these. Now, if you notice on the LED, you can control the colors of them. Usually red and orange are they require about 2 volts apiece. Green and blue require a little bit more, 3, maybe 3.3. I'm not sure if this makes the distinction or not, but I'm going to leave them red for now. On one side, it'll say anode. There we go. That is the positive side. The other side it says cathode, that's the negative side. So I'm going to connect my positive. Anywhere along here I can start a wire. It's all connected together. I'm going to connect that to my positive side down here. And then on its positive side, I want it to be red. And then, let's see, for the wires in between, I'll go, oops, I want that to be red. I forgot it stays highlighted. For wires in between, I want to connect these, the negative side of this one to the positive side of the next. And then the negative side of this one to the positive side of the next. And last but not least, I want to connect the very last one, the negative side, to the negative rail down here. So that creates one series circuit. I got the battery from the positive out to this this LED, 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 and then back to the negative. And when I'm ready, I can go up here and say start simulation to have it start. Oh, I can actually also use the space bar. Ha ha ha, fancy. Oh no! Everything's blowing up. This is bad. So, and it's warning me already. Current through the LED is 146 milliamps, while the absolute maximum is 20 milliamps. So, no bueno. We don't want to blow up our LEDs. That is where the resistor comes in. All right, let's delete this wire. And instead of that wire, I'm going to use this resistor to resist the current, to basically limit the amount of current that's going through these LEDs. I'm going to make it 220 ohms. There we go. Well, actually, let's start it off on what it was before. It was 1 kilo ohm or 1000 ohms. Hit the space bar again to test it. They are on, and they're not exploding. Yay, not burning. And I can adjust things here. Let's say if this was, well, 500 ohms instead. Oh, they got a little bit brighter. If this was 100 ohms. Okay, they got a little bit brighter. Oh, but now it's warning me. Okay, I'm at 25.9 milliamps. So the recommended is maximum of 20. So it's, let's see, this is the usable lifetime of the LED may be reduced. So nothing's burning out, but it may not last as long in general because of that. Okay, so 100 is too low. I'm going to go back to 200. Okay, it's happy at 200. And there is my first 3 LEDs. I have them in a series circuit from the battery through a resistor, anode to cathode, positive to negative, LED, 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 and then back to the negative. If I want to make another branch and have more of these, I'll do another branch. I can't put them right on top here because then they're connected to these actual things. So I can put them somewhere else. I'm going to put them over here. LED, and on this one we're going to add a switch. Ooh. I'm actually going to spread this out a little bit more. Let's move these up here, and let's add a fourth one. Why not? There we go. I'm going to add another resistor because I learned my lesson from the resistors, and say, okay, go from the positive to here. And then let's search switch, nice little search bar. So I'm going to grab the push button, and we literally have these same things. We have a couple different versions of switches, but this fits right across the middle there, so I can put it right here and say, okay, this resistor is in, come on mouse, this resistor is in right here. It's connected to one side of the switch. The other side of the switch is connected to this row and this part of it. So now I just need some wires connecting my LEDs. 1, 2, 3. And then this one I need to bring all the way down to that negative row. So this one takes up a little more real estate, but that's all right. So I'm going to push my space bar to start the simulation. These turn on, but the other ones don't because I gotta push the button. And for this one, I gotta push and hold on this type for it to work. Now these are a little dim, so I don't want it to be 1 kilo ohm. I want it to be, let's try 1 ohm. That's unhappy. Yeah, it's probably a little too low. Let's make that 50 ohms. Let's test it. Yeah, that's not bad. Because I have more bulbs here, that's taking up more of the voltage, 2, 4, 6, 8 volts. I only need 1 volt across this. So to get the right current, I don't really need as much resistance. But you can test this in here without burning out any bulbs. So there we go. We have this in parallel, and you can make more parallel branches of this as we go. Just know that each column here is connected, each of the rows are connected, so you can connect off the battery by jumping off any of these points. And let's try to build your circuit in here a little closer to real life and what that would actually look like. All right, you got this.